the relationship between the intensity I of light source and the distance d from the light source can be modeled by I equals k over d squared. Pablo measures the intensity of a light source at different distances. The data collected is shown in the table. Pablo finds the sum of square residuals in the form of this. Find the exact value of C. This is a linear regression line y equals mx plus b. When x equals xi, we got this yi. It's called observed value. If we use this linear regression line, we can get this value we label as y hat. This is called predicted value. The distance between observed value and predicted value is called residual. So this distance is called residual. So residual equals, we will use absolute value to show the distance. Y I minus y hat I. Sum of square residuals. Normally we will use this S as RES to represent the sum of square residuals. Sum, we will use a summation symbol. Square residuals, so we will square these residuals, which means yi minus y hat I squared. This formula is not given in IB formula booklet. You need to remember, we are given this I. This is an observed value. We need to figure out this predicted value I hat. When we substitute 1 for d, we got k over 1 squared. Substitute 2 for d, we got k over 2 squared. Substitute 5 for d, we got k over 5 squared. Let's organize. I hat. K over 1 is k. K over 2 squared is k over 4. K over 5 squared is k over 25. Based on the formula of sum of square residuals, we got 42 minus k squared plus 11 minus k over 4 squared plus 1.5 minus k over 25 squared. We are given sum of square residuals is this. In other words, this equals 1.0641 k squared minus 89.62 k plus c. We are looking for exact value of c. Let's analyze this equation. On the right side, this c is a constant. So we just need to figure out on the left side of this equation, what's the constant number. Then we add them up. equals C. For the first expressions, we got 42 squared as a constant plus. For second expressions, we got 11 squared as a constant. For these expressions, we got 1.5 squared as a constant equals C. Let's use a calculator. C equals 1887.25. Let's go to B. Hence, find the least squares regression curve of the form I equals K over D squared. We know sum of square residues equals 1.0641 K squared minus 89.62 K plus 1887.25. Least squares regression curve means we are looking for the minimum value of sum of square residues. Let's go to calculator. Let's type this function into f1 of x, then enter. We didn't see any graph, so we need to change this window. Go to menu, go to 4. Let's go to zoom out 4. Then go to this origin, click. We could see this minimum point now. Then go to menu, go to 6, go to 2, minimum. We got this coordinates. So when K equals 42.1, sum of square residues will have a minimum value. By graphing, sum of square residues has a minimum value at K equals 42.1. Therefore, I equals 42.1 over D squared. This is the form we are looking for.